Okay, so we're talking today, guys, about vectors. All right, vectors is a physics term that you guys will see from time to time. Everything in here that we do mathematically with vectors, you guys already know how to do. We're just talking about different vocabulary, all right? Many quantities in geometry and physics, such as area, time, temperature, can be represented in a single number. Other quantities, like force and velocity, involve magnitude and direction. All right, magnitude and direction. You guys know what both of those two words mean. Magnitude is length, direction is slope. So we already know how to figure out those two things. When they talk about what is the magnitude of this, what is the direction of this, you guys know. A vector is a directed line segment. Do you guys see? This is vector PQ. Do you see how this is a line segment? Because it has endpoints, yes? It has an initial point and a, terminal point. This is what makes it a vector. Initial is where the line segment or the vector does what? Starts, good. And the terminal point is where it does what? It ends. So it has a length, it has a specific length that we can calculate, and it has a specific direction that we can calculate, which is a slope. So you see it's written, a vector is written like this. Kind of looks like a ray, but not really. If I didn't give you a picture, you guys could tell what the end point was and the beginning point, the initial and the starting, by where the letters were in comparison to the notation. Y'all see that? Okay, just a directed line segment. Like I just said, we have an initial point where it starts and a terminal point where it ends. And then we have something called the magnitude. Magnitude is the same thing as length. Do you guys know how to find the length of something? What formula do we use for length? The distance formula, right? So this is the distance formula. Write it down if we don't remember it. Subtract the x's, subtract the y's, square them and add them together. Right? If they ask you for the magnitude, this is how they would ask that question. That's not double absolute value. That denotes magnitude. It is like two absolute values. If something, or if two vectors have the same magnitude, meaning the same length, and they have the exact same direction, when we talk about direction, that's just slope. You guys remember the slope formula? y2 minus y1 over x2 minus x1. Yeah? If you have a directed line segment that has the same magnitude and same direction, they're called equivalent. What does the word equivalent mean?
The same.
The same. So if they're the same length and they have the same slope, then they are equivalent vectors. Everybody understand that? Okay, the way that vectors are written, I just told you, if they're written with their initial point and their terminal point, it looks like this. But another way that you guys see vectors written, and this is how you'll see it mostly, is right here. Vectors are denoted by lowercase boldface letters. Do you see how U, V, and W are they're small and they're bolded? Do you guys see that? So you should understand that, oh, vector U, this is what it looks like. Vector V, vector W. It's lowercase and it's bolded. So in a question like this that show that U and V are equivalent, what did I just tell you the two things that they have to be if they're equivalent? They have to be the same length and they have to be the same direction. So let's talk about the length. The magnitude, right? Magnitude, same as like magnitude. So let's find the magnitude of vector V, and we'll find the magnitude of vector U. That's just the distance. So here is V, right here. We have our points, right? So 1 minus 4 squared plus 2 minus 4 squared. 1 minus 4 would be negative 3 squared plus negative 2 squared equals square root of 9 plus 4. So vector V's magnitude is the square root of 13. Agreed? All right, let's do U. Again, I'm starting at 0, 0, then I have 3, 2. So I'm going to say 0 minus 3 squared plus 0 minus 2 squared. So negative 3 squared plus negative 2 squared. I get 9 plus 4, which is what? Also square root of 13. So are the magnitudes of these two vectors the same? Yes. So now let's find the direction. Well, direction I told you guys was just what? The slope. So y2 minus y1. So I'm going to say 4 minus 2 over 4 minus 1. So 2 over 3. Agreed? Okay. So then on the bottom, or my vector u, y minus y, so 2 minus 0 over 3 minus 0, I get 2 over 3. Are the slopes the same? Yes. So you just proved that these two vectors are equivalent because their magnitude and their direction are the same. They're the same length and they have the same slope. How mathematically that worked out? Yeah. Yes? Okay. We're going to be good to go then. All right, your directed line segment, whose initial point is the origin, often most convenient representative of a set of equivalent directed line segments. Guys, we're talking about stuff that is in standard position. When you talk about standard position, it's kind of like in, like we say in standard form, right, where our exponent, the highest exponent's the first, something like that. You're going to write your vectors in component form. Look at what this says. This is how you make that bold-faced V. They're going to give you 2 points. They're going to give you the initial and the terminal, and you're going to write it in vector form. This is super easy. What I need you to pay attention to is the notation. If you write your vector like this, is that a vector? No. What is that? That's a point. If you're going to write vector notation, do you see how you have a little like V kind of thing, arrow, whatever? Vector notation is not parentheses. You will get points taken off if you write it in parentheses. Understand? Okay. So when we talk about finding the component, form of a vector, here are the formulas. Now, somebody asked me, A period, are we going to get these formulas? To me, this is more confusing than anything. I'll explain what this says here in a second. But you're going to be given 2 points, right? The initial and the terminal. Right? We just talked about when I just gave you guys vectors, stuff, or I gave you a directed line segment. We changed it into a vector. To find the vector itself, notice what you do. Do you see your P1, P2, Q1, Q2? You subtract Q and P, the first ones. You subtract the second ones. That gives you your vector form. Now, would you agree that when you do that, you're finding your change in Y and your change in X? So when you go to find your component form, then the magnitude, all you have to do is this. Now, I understand you guys are like, what are you talking about? Watch what I'm talking about here. We'll do it with numbers. First thing I can tell you that is the most important for you to write down with this is terminal minus initial. If we get that order wrong, then our problem is wrong. In order to find the component form, given the 2 points, you have to take the terminal minus the initial. So what is my terminal point? -1, 5. Minus my initial is 4, -7, correct? Now I'm going to say this a whole bunch of times, and it should hopefully stick in your brain, but first goes with first. Second goes with second. What I mean by that, I have -1 minus 4. You guys see that? First goes with first. Then the second part of my vector is going to be 5 minus -7. So simplify that. My component form of this vector, what is -1 minus 4? -5. And what is 5 minus -7? 12. There is the component form of your vector. You keep the first with the first, second with the second. Now, if they ask you for the magnitude, once you have your vector, you don't have to worry about your x's and your y's and subtracting and all stuff. Your magnitude right here, you take v1 and v2. So I'm going to say negative 5 squared plus 12 squared. And I take the square root of it. So the magnitude, what is negative 5 squared? 25, thank you. What's 12 squared?
144.
What is 25 and 144? 169. What's the square root of 169?
13.
So the magnitude of this vector that you just found is 13. So once you get your vector in component form, all you do is square each piece, add it together, take the square root to find the magnitude. You don't have to use the whole distance formula, because you've already found the difference in the x's and the difference in the y's when you found the terminal minus initial. Does that make sense? Biggest thing, guys, is to remember it's terminal minus initial. It's not the other way around. If it was a plus in the middle of the equation, it wouldn't matter, but it's not. There's a minus sign, so you got to keep that order correct. All right, now we're going to talk about operations that have to do with our vectors. This is the same operations you guys have been doing with order of operations and stuff since you were in the 4th or 5th grade. All right, we're going to talk a little bit about graphing. We're not going to do any graphing, but we're going to talk about graphing here. If this is my initial vector, everybody see this initial vector? Do you see how it's going it's going up? Do you see how this vector was changed? What happened to it?
Smaller.
It got smaller by about how much? A half, right? So all we did was just cut it. We divide it by 2. We cut it in half. This is called scalar multiplication. It's just distribution. That's it. What happened here? From my initial green to this vector here. It doubled. We multiplied it by 2. What about this vector here? It became negative. What happened to the direction of it? Right? It flipped. Just like a reflection would do. Just like going from positive to negative, that sort of a thing. What happened to this vector here? All right, it became negative, and we multiplied it by 1.5, right? That's all that we're doing here, guys. When they ask you about adding vectors together or subtracting them, is you're taking the two vectors and you're adding them. The sum of one, sum of the other. Do you see how you take u and v and you just simply put it together? When you put it together, you're adding them. That's it. This is how we add. I know this looks crazy, but let's look at it. All right, if I have, here is one vector. You guys see u? And then here's v. If they want us to add them together, look what they did here. How'd they get the first part? What did they add? The first part of u and the first part of v, right? How did we get the second part? First stays with first, second stays with second, every time. What about this? This is called a scalar multiple. What do we call this? What is this? If we hadn't talked about this today, what would you guys have told me was happening with K? Distribution, thank you. That's all it is. Scalar multiple is just distribution. So when we go to multiply by a negative, do you guys see how when you multiply by a -1, what does it do to the signs? When you multiply something by a negative, what does it do to the sign? It changes it, becomes negative. If it was already negative, it becomes positive, all right? You guys can handle this, absolutely no problem. Let's work through these. What is A asking us to do? What does A say? Guys? To do what? What is A asking us to do?
Find the vectors.
Times it by 2. 2 times vector v. So -2, 5. This is how you guys would show me your work. What do you want me to do with 2? You want me to distribute it, correct? So what does this vector become?
Negative 4.
-4, comma, 10. That is it. That is it. The notation, guys, the notation is important. Don't put it in parentheses. But that's it. What about B? What is B asking you to do?
Subtract.
Subtract. So you're going to take the W vector, which is 3, comma 4, and you're going to subtract the V vector, which is -2, comma 5. Now, where y'all will make your mistakes is if I give you W, X, Y, and Z vectors, and I tell you to say W minus X, you might look at the wrong one. All right? You have to pay attention to what you're doing. But if I'm going to use my vector operations to combine these two, what did I tell you at the very beginning? First stays with what? First. So this says 3 minus -2. Correct? Then the second part is 4 minus what? Okay, so let's simplify. What is 3 minus -2? 5. And what is 4 minus 5? -1. Now, if I said to you guys, it doesn't ask you this, but if I said to you, what is the magnitude of that vector? How would you find the magnitude? You don't even have to plug in anything. 5 squared plus -1 squared. So it's 25 plus 1. The magnitude, or the length of this vector, is the square root of 26. Questions? The last one says V plus 2W. Whoa, now we're getting fancy, right? So if you're going to show me your work, you're going to say, okay, V, what's V?
-2, 5.
-2, 5. And then it's plus 2 times W, which is 3, 4, correct? So show me what the vectors represent numerically. And now, order of operations, guys. Are you going to combine first, or are you going to distribute the 2? Distribute the 2, good. So this becomes vector -2, 5 plus what? 6, 8. Perfect. Now to combine this into 1, first and first. So -2 plus 6 is what? 4. And 5 and 8 is 13. Perfect. Now if I said, what's the magnitude? How'd you find the magnitude? Magnitude would be 4 squared plus 13 squared. So 16 plus 169. I can't write. What's 16 plus 169?
185.
Square root of 185. And then if that reduced, you'd reduce it. The question didn't ask for that. I'm just saying if it did, that's what you have to do. Does that make sense? All right, so when we talk about different operations, guys, these are all the vector operations. But look at this. This is all stuff that you learned probably in elementary school. Number 1 says U plus V. Vector U plus V is the same as vector U plus V plus U. Is 3 plus 2 the same as 2 plus 3? Yes. All right, 2 says if I add U and V and then add it to W, that's the same as if I added V and U and added it to V and W and added it to U. Correct? All right. 3, if you add anything to 0, you get that same thing, correct? So if I add any vector and I add 0 to it, I get 0. If I add complete opposites, positive and negative, I get 0. Look at here. If I multiply D times U and then multiply by C, it's the same as C times E times U, right? Plug in numbers there. For 6, again, what's going on with U?
Distribute.
Distribute, good. Same thing with 7, right? What do we do with C? Distribute. Look at 8. If I times anything by 1, I get itself. If I times anything by 0, I get 0. Correct? All right, that's it. So you guys are good.